Okay, class, what we want to do is talk about the central nervous system. The central nervous system consists of the brain and the spinal cord. The brain and the spinal cord. What I want to talk about with this one is the spinal cord. Then we'll do several little videos on that, and then we'll talk about the brain. Okay? So let's get started. The spinal cord originated from something called the neural tube, okay, which we showed in the last video. So the neural tube formed the spinal cord. This would be the neural tube, okay, and this would be a central cavity. Here we have some blast cells, neuroblasts, that's going to form the neurons of the dorsal root ganglion. Now, one thing I want you to know about the spinal cord, all sensory comes in through the back. This would be the back of you. And all motor comes out through the front. So the alar plate is where you develop neurons that are sensory coming in. And the basal plate, motor going out. So remember from my last video, sensory is afferent, motor is efferent. Okay? All right, so we'll go a little further. All right. The spinal cord begins at the foramen magnum. Now, technically, where it begins, is at this area here called the medulla oblongata of the brain. The medulla oblongata of the brain. But if I talk about the skull, which you'll be looking at later, here's that big hole. And that big hole is where the medulla oblongata goes through, which is going to continue with the spinal cord. So the spinal cord is a continuation of the brain meeting at the medulla oblongata. Okay, oblong area. All right. The spinal cord ends as an intact entity at L1. Now, what do I mean by that? Right here at this area called the conus medullaris. It almost looks like the ace of spades if you play cards. That's where it ends. Now, L1 is about the belly button level for you. So you know you're going to need a bunch of nerves going further down than the belly button, right? So the cord as an intact unit ends there. But then it sends nerve fibers down further. And that's what we're going to call the cauda equina, the tail end of a horse, because they look like, the little feathery horse tails. All right. Now, it provides a two-way communication, which means sensory in here, we're going to be talking about, goes up to the brain. It's ascending. Motor comes down and is descending. And we'll be talking about tracts. Contains spinal reflexes, even like your knee-jerk reflex. Okay, let's go a little further. All right. The spinal cord is protected by the bone, meninges, and cerebral spinal fluid. Plus, it has a cushion of fat and a network of veins in the epidural space between the vertebrae and the dura mater. So let's go to that. Let's see what we got here now. All right, first of all, this is the whole, I just picked up just a typical vertebrae. Your spinal cord is in that hole. You'll learn this is called the vertebral foramen. Foramen means hole. It's in there, the vertebral foramen. So when you look at a picture like this here, you find a picture there. Here would be this picture. What you have here, this would be the spinal cord. But right here, this is the bone. So that's a bone area right there. All that's bone. Okay. So right in here are the meninge areas. These are the meninge areas that you have, okay? So what you have here is basically this. Here's the bone. Then you have some areas which would be fat and a network of veins in the epidural space, okay? Then you come down from the epidural space. See, I don't know how many of you have ever heard of an epidural anesthesia. As a gynecologist and obstetrician, I did those when we were, to deaden a woman to deliver a baby. Then we come down to this right here. So in other words, we're looking at the meninges. Let's first name the layers of the meninges. So we got the bone taken care of. So now let's go to the meninges. Okay. with the meninges, you have an epidural space. That's a space above and outside the first layer of the meninges called the dura mater. Let's go back. That would be, if this is the dura mater, that would be outside of that. Okay? Dura mater. And in that space would be fat and a network of veins in this epidural space. Okay? So we go next then to the dura mater itself, which is a tough connective tissue layer. Okay? And that would be this right here. That layer right there. Okay, let's go back. Then we go to the subdural space, which would be this layer here, which is hard to see. It would be a layer right there in between the two. Then we can come to, let's go up here, to the arachnoid layer. And let's say this is the arachnoid layer up in there, and that's where your cerebrospinal fluid would float. At least under this layer. The arachnoid layer looks spidery. Now you can't really see it on this one real good. It looks, but it's a spidery looking layer. Okay? And actually the layer itself is not spidery, but underneath the layer is where you see the spidery stuff. Let me see if I see a picture of that anywhere. Right in here, you can kind of see some spidery stuff right there. See, here's the arachnoid right there. And underneath there, if I blow this up a little bit, you can, so the subarachnoid space, which is right there, you'll see, and you can do it better in your book, you can see that spider layer. Now in that spidery looking layer, which is the subarachnoid space, that in those spidery looking areas, that's where the cerebrospinal fluid floats. That spinal fluid, okay? See, that's that cerebrospinal fluid. Then we go to the pia mater. And the pia mater, which is a delicate mother called, it actually directly sticks to the spinal cord. It sticks to the, so you heard of meningitis, that's an infection of those layers, okay? So it has bone, meninges, and cerebrospinal fluid. And you got that cushiony stuff right there, which is the epidural space. The CSF is in the subarachnoid space, which on this drawing here would have been in that spider layer area. All right. Let's go a little further. Now, in order to hold, okay, think about just wiggling around side to side. You wiggling side to side. In order to hold the spinal cord so it doesn't wiggle, if you're wiggling so it doesn't shake, you have some little extensions on each side of the spinal cord called the denticulate ligaments. The denticulate ligaments. I wish I had a good picture of that. Okay, class, what you see is these denticulate ligaments. I found something. The extensions of the pia mater that secure the cord to the dura mater. So what they're going to do, now think about this. They're going to go through, here would be, they're on the pia mater, they're going to go through the arachnoid and then hook to the dura mater. And they're going to do it on each side. So if you hold on this side and you wiggle around, the cord can't wiggle because you're being held on this side and that side. And the reason they're called denticulate, like teeth, is because they're not continuous down. See, they're like a tooth and then another tooth and so forth. So they're extensions of the pia mater to the cord. Then another thing to protect the cord, see, if you move it around, you don't want that. Okay, let's think about it. You don't want the cord to be bouncing up against the bone. If so, you'd have inflammation and swelling of the cord. So the denticulate ligaments help. The fat that you saw up here helped, because here's the bone. And something else is going to help. And that's the filum terminale. Now let me tell you what the filum terminale does. The dura mater comes on down. Now here would be, let's say, the dura mater coming on down. And what the dura mater is going to do is, it's like a piece of tape, tape it to the sacrum. So it's pulling down, like if you had a drape around the spinal cord and pulling down and taping it to the sacrum, to the bone. Now what that would do is straighten that cord and disallow it to wiggle, particularly at the tail. So what's the three things that help you not bounce your cord around and hit it up against the bone? The fat in the epidural space, the denticulate ligaments, and this filum terminale, which is the continuation of the non-nervous tissue. Listen, the non-nervous tissue down and is being hooked to the sacrum. All right? So we go further then. Now see, here is doing a lumbar puncture. Like if you had meningitis and we wanted some cerebrospinal fluid. I don't know if anybody's had one, but you can look at a video maybe on it. What we do is you would sit on a table, let's say, and I would have you put your head almost down into your lap, bend down. Nurse would help you. That would open up these spaces, these vertebral spaces in the vertebrae. Okay, intervertebral spaces. Then what would happen is we take a needle and stick it through and go into the subarachnoid space. Now we always do it in the lumbar region. Why? Because even if we went too far, we can't hit the spinal cord as an intact unit. Why can't you do that? Because the spinal cord ended as an intact unit as L1. So we're around an L4, L5. Okay? So that's just to show you this particular aspect there. And here's that filum terminale there coming down, back of sacrum taped. Okay? So we go a little further. All right. Now, we look at the spinal nerves. Okay, the spinal nerves, which were these here. See, these finally form those spinal nerves. You have 31 spinal nerves. 31 spinal nerves. These are these little nerves coming out, these spinal nerves. Okay, 31 of them. We'll be talking about those when we talk about the peripheral nervous system. 31 pairs, one on each side. You have some enlargements of the spinal cord, the lumbar enlargements. Now, the reason the spinal cord needs to enlarge in a few areas is this. You need more nerves coming out. Think about it. Right up in here, you need nerves going to your arm. Okay? That's the cervical enlargement, up around the neck. The lumbar enlargement would help me send nerves to my legs. Okay? Serving upper and lower limbs. Okay? Cervical and lumbar. Because I need more nerves if I got to go to my legs and my arms. The cauda equina I mentioned to you before. Now, if the spinal cord ends at L1, how are you going to get the nerves down further? So though the spinal cord ended, you have this horsetail looking structure, the cauda equina coming down, and that's going to take care of the nerves after the cord end. So let's think about this. Here's the end of the cord. That's the conus medullaris, that swollen area. Now here come nerve fibers down that look like the back of the horse. So the cauda equina is the nervous continuation, the nerve tissue continuation after the end of the cord. Whereas the filum terminale is the non-nervous tissue, which is the dura mater coming down to tape the cord to the back of the sacrum so it doesn't bounce around. Okay? So cauda equina, filum terminale. Go back, study it. All right, let's see where we are. So the lengthwise grooves, so we now go to the spinal cord. The lengthwise divide the cord, these are the grooves, into a right and left side. Okay? So what we have in the front here, this groove here, which I guess would be there, little 25, would be a ventral median fissure. See, it's the front, remember. It's your back here. A ventral median fissure. And right here is a dorsal median sulcus right there. And then the communication between one side of the cord and the other is called a commissure. We're going to end this video right here, number 10, and then we're going to start another one.